All right, if you're in IT, I bet you know this feeling. You've got that PowerShell script. It was working perfectly yesterday, and then today, bam, it just refuses to run. You want to just throw your monitor out the window. It's a headache we've all had. And today, we're going to finally solve it by untangling the really confusing relationship between WMF, .NET, and PowerShell itself. Yeah, this screen probably looks a little too familiar, right? You've got a script, you know it's good, you wrote it. It worked yesterday, it works on your buddy's machine, but for some reason on this one server, it just dies. And that's when you start questioning everything. Your code, your sanity, maybe even why you got into IT in the first place. But what if I told you the problem usually isn't you? It's not your script. The real issue is often buried deep down in the layers of technology that PowerShell's built on top of, kind of like a hidden engine room that most of us never even see. Well, today we're going to pop the hood and actually figure out what's going on in there. So let's treat this like a little investigation. We've got our crime scene, a failed script, we have a mysterious error message, and we've got a few key suspects. Our mission is to figure out what's really happening when our scripts decide to just give up. And here it is, Exhibit A, our prime piece of evidence. I would bet good money that almost every single one of you has seen this exact error. And it's so infuriating because it looks like a simple permissions problem, but the real cause, well, it's often something way more fundamental. So who's the culprit here? Is PowerShell itself just broken? Is it the .NET framework that's messing with us? Or is there some other piece to this puzzle that we haven't even thought about yet? This is the central question we are going to get to the bottom of. To solve this mystery, we need to meet the suspects. So let's break down the core components that actually make PowerShell work. Once you see the role that each one plays, trust me, these kinds of errors are going to start to make a whole lot more sense. Okay. First up is the Windows Management Framework, or WMF. The absolute best way to think about this is as the entire management toolbox for Windows. It's not just one application, it's a whole package that includes PowerShell, desired state configuration, WinRM, the core stuff for automating and managing the OS. Next, we've got the .NET Framework. Now, if WF is the toolbox, then .NET is the engine that powers every single tool in that box. It's the foundation. It handles everything from managing memory to security. PowerShell isn't just using .NET, it's literally built on top of it. Without .NET, PowerShell it doesn't exist. And this car analogy right here on the slide just ties it all together perfectly. Think about it. .NET is the engine. It provides all the raw power. PowerShell is the steering wheel. It's the thing you use to tell the car where to go. And WMF? That's the entire dashboard, all the advanced controls and gauges that really let you manage the whole system. You can't drive without the engine, but it's that dashboard that puts you in total control. Okay, so we get the components now, but here comes the plot twist. Around 2016, the entire PowerShell landscape just changed. It basically split into two parallel worlds, and understanding this divide is the real key to solving most of the scripting problems you run into today. You see, for years, as this timeline shows, the WMF version and the PowerShell version were locked together. WMF 4 came with PowerShell 4, simple. But that all came to a screeching halt with WMF 5.1. Why? Because Microsoft completely changed its strategy. They decided to make PowerShell open source and cross-platform. And to do that, they created PowerShell Core, a totally new version that was completely separate from WMF and the whole Windows-only world. This was the moment everything changed. And this slide right here perfectly shows the two worlds we live in now. On the left, you've got the WMF era. That's your PowerShell 5.1, the one that's baked into the Windows OS. Then on the right, you have the modern era. That's PowerShell 7 and beyond. It works on Windows, Mac, Linux. You install it separately. And here's the most important part. It does not use that old .NET framework. It runs on the modern .NET runtime. This table really breaks down the critical differences. The old .NET framework, Windows only. And honestly, it's pretty much in maintenance mode now. It's not getting cool new features. That's the engine for PowerShell 5.1. The modern .NET runtime, though, is cross-platform, and it's where all the active development is happening. That's the engine for PowerShell 7. They are not the same thing, and yep, they can live right next to each other on the same machine. So, now that we know there are two different PowerShell worlds, what tools should you actually be using for your day-to-day work? This is where we shift gears from the why to the what to do. This is practical advice you can start using, right now. Let's talk about your editor first. Look, the PowerShell ISE was great for its time, but its time is over. As you can see in the table, its development is frozen, and it was only ever built for PowerShell 5.1. It just plain can't handle modern PowerShell 7. The official, actively developed replacement is Visual Studio Code, which supports both worlds beautifully. The takeaway here is simple. If you're still using the ISE, it is absolutely time to switch. So what does the perfect setup look like today? It's really simple. First, keep PowerShell 5.1. Do not get rid of it. Second, install the latest PowerShell 7 for all your new scripting, especially for talking to APIs or doing cross-platform work. And third, use VS Code as your editor so you can easily switch between both. This setup really does give you the best of both worlds.
I'm going to repeat this because it is so important. Do not uninstall PowerShell 5.1. A ton of critical Windows management modules, like the ones for Active Directory and Group Policy, were built specifically for that old .NET framework. They will not work in PowerShell 7. If you remove PowerShell 5.1, you're going to break your ability to manage core parts of your Windows environment.
Okay, now that we understand the engine, the two different worlds, and the right tools for the job, let's circle all the way back to our original mystery. It's finally time to solve the case of that super frustrating error message. Here it is again, the infamous error. But now that we understand the difference between WMF and .NET and PowerShell 5 versus 7, we can see this has nothing to do with the engine. This problem isn't some fundamental failure, it's something else entirely. This error is caused by PowerShell's execution policy. And here is the single most important thing to understand about it. Execution policy is not a security feature. Let me say that again. It is not a security boundary. Think of it more like a safety rail. Its only job is to stop you from, say, double-clicking a script you downloaded and accidentally running it. It's about confirming you mean to do something, not about system security. And the fix is this one. Simple command. Setting the execution policy to remote signed for just your user account tells PowerShell, hey, I trust the scripts that I write on my own machine. It's safe, it's standard, and it's the best practice way to solve this problem for good. And just like that, the mystery is solved. By understanding the machinery underneath PowerShell, the errors that used to seem so random and frustrating now actually make sense. So the question is, with this new clarity, what's that old nagging automation problem that you're going to go tackle next?